Hi guys, this is just a short lesson you'll need before we talk about polar form. We need to talk about the unit circle, and specifically sine, cos, and tan are definitions. So far for junior cert, your definition will be that sine A is when you have an angle A in a right angle triangle. The sine of that angle will be the opposite over the hypotenuse. The cos is the adjacent over the hypotenuse, and tan is opposite over adjacent. The problem with this definition is that it only allows for A to be an angle between 1 and 90. Um, if A has a value of 0 or 90 or anything bigger than 90, these definitions make no sense. So the unit circle is our new definition for sine, cos, and tan, and it chimes with the old one. So we'll have a quick look at it here. So a unit circle is a circle of radius 1, and any point on that circle might have a coordinate x, y. Um, this angle here, A, is how far you've kind of come around. Okay, so the radius is 1, how far you've rotated the radius from this point, say. Well, if we look at the coordinates, the x is how far across we've gone, and the y is how far up we've gone. So there's x is that distance there, and y is this distance here. So what we get inside our unit circle is a right angle triangle of hypotenuse 1, base x, and height y. So we can work with our old definitions. We can say, well, sine A, the opposite side is y, over the hypotenuse is 1. Okay, so that says y equals sine A. And we can also say cos A is the adjacent side of the hypotenuse, which is x over 1. So that says x equals cos A, which means this coordinate x comma y can also be written as cos A sine A. Okay, so our new definition for cos is it's the x coordinate the angle makes on a unit circle, and our definition for sine is that it's the y coordinate an angle makes on the unit circle. So this is useful because now if we look at an angle that's bigger than 90 degrees, we can still say, well, that still has an x coordinate and a y coordinate. There's the value for cos of whatever this angle is, b, and you'll see it's negative, so cos can be a negative now or positive. And here's the value y, the y coordinate is here somewhere. So sine there, which is still positive, but it'll be negative when you rotate around further. So we'll just have a look at an example here. If you were told that the sine of 30 is a half, and the cos of 30 is root 3 over 2, which is about 0.87. Well, here's what your unit circle would look like for 30. Okay, your hypotenuse there is 1. If you like, there's your right angle triangle. So the base of that right angle triangle, which is your cos of 30, is 0.87. And the height is at 0.5. Okay, there's 1, minus 1, 1, minus 1. Unit circle, radius of 1. So knowing that, if you're asked to find sine of 150, well, you come down here and you say, now sine of 150, well, this line here and this line here are mirror images of each other. They've got a symmetry. That's a 30-degree angle there. So for this angle 150, 30 is called a reference angle. So the reference angle is 30. That tells us that the y coordinate here is going to be the same as up here. So sine of 150 is 0.5. The x coordinate down here for cos of 150, well, that's the mirror image of this x coordinate. So if this one is root 3 over 2, this one is minus root 3 over 2. You can check that in your calculator. It'll spit out the same results. 210 is the next one. It also has a reference angle of 30 degrees. Okay, that angle there is 30 degrees. So we can look here and say, well, this is again symmetric with our original image, this time through central symmetry in the origin. So we can again say, well, I know what my x-coordinate's going to be. My x-coordinate along here is the same as it was up here. Okay, in fact, these are mirror images of each other as well. So my x-coordinate for cos of 210 is going to be, well, I'll tell you what, I'll leave that. I'll let you write that down yourselves. Maybe pause the video if you're not sure. Okay, and then unpause it once you're happy. So it's going to be minus root 3 over 2. Okay, and again, you can pause the video here for sine of 210. See if you can write it down yourself. Okay, so sine of 210, well, that's your y-coordinate here. So it's still going to be a half, but this time you're down in the negative part. That's minus 0.5. And again, check them out in your calculator. You'll find that you get those answers if you do cos 210. The last angle I want to look at here is 330 degrees. Again, 330 will have a reference angle of 30. So it's symmetric with our original diagram. So maybe see if you can write down cos 330 and sine of 330 there. Maybe pause the video until you get it. Okay, the cos of 330 is the x-coordinate. Well, that's a mirror image of our first diagram. So that's our same 0.87 or root 3 over 2. It's positive. And the sine of 330 is our y-coordinate, which is over here. Our y-coordinate is minus 0.5 again. And if you wanted to write out that coordinate, that would be root 3 over 2, 0.5. Minus 0.5. So that's the unit circle, and it's extremely useful, and it's something you should be able to work with without a calculator, even though your calculator will do a lot of this work for you. Having a good understanding of this is going to help a lot in later parts of the course, as well as in complex numbers. So here's a quick example for you to try. You can check all of these answers with your calculator, but when you're finished now, just try, given that sine of 60 is root 3 over 2, cos of 60 is 0.5, can you find the sine of 120, cos of 120, sine of 240, cos of 240, sine of 300, cos of 300. And obviously all of these angles have 60 as a reference angle. Okay, so give that a go. Thank you.